Before beginning, it is important to have a firm grasp of the nature of a coordinate system, as they will be the primary tool with which we will be working. A coordinate system is a way to uniquely identify each point in a defined space, given an ordered set of numerical coordinates. Each number represents the distance from the point to one fixed reference line, called an axis. Each of these axes is perpendicular to each other, and their intersection is called the origin. The most common implementation of coordinate systems pertains to graphing functions. A function assigns one value, the input, to another value, the output, generally based on an algorithm or formula. For instance, given a function that doubles a number and then subtracts 4, by inputting the number 3, the number would be doubled, 6. 4 would then be subtracted from it, outputting 2. Therefore, 3 would be associated with 2 in the form of an ordered pair, 3, 2. This point in two-dimensional space would be marked as a point on the line of the function, which is the collection of all inputs matched with their respective outputs. However, the relationship between the two numbers in a coordinate system does not need to be so strict. In fact, they do not need to be related to each other at all. Any sets containing two non-imaginary numbers can be plotted on a coordinate plane, no matter the connection between those numbers. Before we can start discussing musical coordinate systems, we must first define a method for converting sound into numerical values. Rather than limiting ourselves by basing our system on the Western 12-note chromatic scale, we can base it on the logarithm of pitch frequency. We can define middle C as 0, with everything higher in pitch than middle C being positive and everything lower being negative. It is important to keep in mind that this allows for continuous pitch, rather than the set of discrete pitches that we are used to. When this is applied to the keyboard, it might look as though the only allowable numbers are integers. But that is because the piano has fixed discrete pitches, meaning it can't play the pitches in between the semitones. This is similar to the difference between a ramp and a staircase. On a ramp, one can stop at any height along the ramp, but a staircase only allows for a set of predefined heights. Sets are composed of ordered pitches. The first element of the set is the distance from that pitch to the y-axis, middle C, or the distance it has moved along the x-axis. The second element in the set is the distance from that pitch to the x-axis, or the distance it has moved along the y-axis. Sets can be composed of harmonic or melodic groups of pitches, depending on the original music or the goal of that analysis. The motion from one set to another, say from 2-3 to 1-5, forms a line, the musical equivalent of voice leading.